Okay, good morning everybody. Welcome to the Centennial Body Shop. I'll take a quick walk around so you can see the place. One day hopefully you can come here and actually do the labs. But this is the body shop. You can see we have frame machines and benches with vices on them and smashed up cars. We got all kinds of fancy welders, plasma cutters, dent pulling equipment, fume extractors, spot welders, alignment machines, infrared lamps, all this stuff. All our welding screens are over there. We got the Fez tools. We got the Pro Spot. We got everything that you'd want to have in a body shop. Then this is our refinishing lab. We got a double prep deck. We got snap-on tools. We got Eurovac. We got eye wash stations, downdraft booth. And another prep station over here. All kinds of cool stuff for you guys to play for when you come. We got our mix computers here. We have our mix room that is locked. With all the paint and all the spray guns and all the headlight aimers for some reason. Spray guns, paint stuff, water-based paint, solvent paint, virtual paint in that red box, gun washers, solvent recyclers. It's about the biggest mix room ever, I think. Then we have our sheet metal lab down here, where we have our aluminum room area thingamajiggy. We got TIG welders, aluminum dent pullers, aluminum spool MIGs, pulse MIGs, TIG welders, banks of steel MIG welders with localized ventilation. We have shears, we have brakes, we have slip rolls, we got English wheels, we got silicone bronze welders, box and pan brakes, all kinds of cool stuff. So that's what's waiting for you guys post-COVID at Centennial College for actually performing some of the stuff that I'm going to show you. And we got one, this is actually a virtual 3D weld simulator. We have 3 of those as well. And then hopefully when you guys get here, we'll be welding up test coupons like it's going out of style. So you guys get really, really good at welding. Until then, let's just learn all the theory stuff. So when you do actually come here to weld, you'll know exactly what you're doing. And you'll be really good at it. Yeah, we got donated vehicles and customer vehicles and hoists and tire machine and balancer over there. Our tool cribs back there. We got training cars underneath this thing for applied mechanical, all kinds of neat stuff for you guys when you come. But another thing of this school is we also have oxy and acetylene plumbed all the way through the whole entire body shop with individual sets of torches. So you can just come here and turn on the taps and you got your welding and cutting gas like ready to go up there. But I'm going to show you guys on this just regular set of bottles, because this would be similar to what would be at your shop if you do have oxyacetylene bottles, or if you had some at home too, they'd be like this. You wouldn't have them plumbed in from an explosion-proof shed outside, right? So the first thing you want to do when you walk up to your bottles is unloop the hose like so, and check out your tanks in your cart or wherever they're located. Like mine at home are just chained to a wall, but they have to be secure so they can't fall over, right? And these, although they can rattle around, they can't fall over, so they are safe. Just on this cart, you want to make sure that the regulators don't bang together. And if they were being transported outside of the cart, the regulator would be off and there'd be like a protective cover that screws on over top of them, right? So the tall one is almost always oxygen, and the short fat one is almost always acetylene in the oxy fuel cutting and welding system, right? So before we want to do anything with these torches, we want to make sure that they're safe to use, right? And the first thing you do when you walk up to a set of torches is you have to make sure these little wing nut guys here are loose. And you can see this one here, like I can even jiggle it, right? It's loose, right? So I know when I turn this on, the pressure that's going through there is not pressing on the diaphragm. Because if you take this little thing out, it's like a brass bullet. And some of these bottles, especially the bigger ones, can be thousands of PSI in them, right? So if this thing is cranked down on the diaphragm, that say 3,000 PSI goes in, it shoves on the diaphragm, shoves on the disc. This thing strips the threads out because they're just brass, and we have a brass bullet projecting out of there. And if you notice, when I walk up to these torches, they are pointing right at my torso, so I would have a nice wing nut shaped hole in my torso, which I don't want, right? So you always make sure that these are nice and loose. So what we do when we shut them off, we make sure that they're spun all the way out so there's no pressure on the spring, right? This one, oh, see, this one is actually tight. It needs to be loosened a bit. So you want to make sure that these are loose like that. So they can jiggle a bit. You know there's no tension on that spring, right? So we got that set. So now we can open the tanks, because when the oxygen or the acetylene comes out of here and goes into the regular, it's just going to stop right there, right? So this is the first spot where we're going to start, is actually turning on the tanks. So we make sure those are safe, and now we can turn on the tanks. And there's a specific way even that you turn on the tanks. So acetylene is relatively low pressure, as you can see from the gauge. It only goes up so many PSIs. It would be really crazy if there's 400 PSI in there, but you notice this one goes to 4,000 PSI. So this one you have to be careful, especially if it's a fresh tank. And everything that's on these things are brass, as you can see. Everything's made out of brass. It's because brass is soft and it seals very well, and it also cannot make a spark, so we can't blow anything up. But what I like to do, and it's Marco, the college's welding tech, that told me to do this, is he likes to, and I like to now, is just lift up on this as you're opening it up. You see the pressure in there? So this one, it's been on here for quite a while. It still has 1,000 PSI on it, right? These can be way, way up there, right? And with an oxygen valve, because it's such high pressure, it's a double seat valve, right? And because oxygen's not flammable, although it is volatile, we open it all the way up and seat it to the top, and so it can't leak out of the top of the valve, right? So with this one though, the acetylene, so the oxygen, we open it all the way and seat it to the top. The acetylene, which is the very, very volatile fuel, this is still, like, from when it was invented over 100 years ago, is the hottest flame that man has ever made, is the oxy fuel flame, right? So this one, we just open it a half a turn. And so if we have to, we could shut it off like that and it's off, right? This one we have to crank and crank and crank to turn it down. So this gets a half a turn open, and we can see this tank's got 220-ish PSI in it, right? Not so high, okay? So now what we're gonna do, so this has gas basically to this one gauge. So we're gonna check these and make sure they're not leaking, right? And I just do this like anytime I change the tank or anytime it's been sort of a while, is you just take a little bit of water, with a tiny bit of soap in it. You just put it on there, put it on there, put it on there, and look for bubbles, and we've got no bubbles, right? I only do this to my torches at home when I actually change the bottles, but here at the school, because so many people use these things, you never know if they've been changed, if they've been pulled apart for a demo, if the bottles are gone. They also get, these are like one of the only mobile torch sets we have in this building, so they go to other departments if they have to cut something. So we're gonna check that, right? So, and it's good. I got no bubbles, we're okay, right? So now we're gonna turn the gas on, and depending on who's teaching you, you may hear different pressure settings. Some people like 5 PSI of acetylene and 7 psi of oxygen, or 5 and 5, or 5 and 10. I like to set it at 5 and 10, and then if I want to put the cutting torch on, it's good to go. I don't have to change anything. Usually for auto body stuff, because we don't get anything really heavy, 7 psi will be lots for the oxygen for cutting procedures, but I like 10, and it's just if you want to heat a bolt, or you have something smashed, you need to slice through like a spindle or melt a ball joint nut off or something like that, it'll definitely be hot enough to do it, right? So we're going to turn this to 10 psi, which is the first little tick on there, halfway to 20, right? So that's 10 for the oxygen. For the acetylene, we're going to turn it to 5 psi. And acetylene is very volatile, and over 15 psi, you can see this gauge maxes out at 15. Over top of 15 psi, it's actually becomes volatile. It can actually ignite all on its own, right? Okay, so now we have gas flowing through the regulator all the way through the lines and to the torch, right? So what we're going to do now is check the other side of the torch and make sure that there's no leakage. We're going to check the torch connections on the handle, and we're going to check the valves as well and see if we have any leaks anywhere. And I don't see anything. I don't smell anything. Acetylene, they do put a smell in it. Oxygen, you can order it with the skunky smell in it, because oxygen can be quite deadly if you increase the oxygen percentage inside the shop, even by a couple of a percentage. It turns things that were flammable can now become flammable, and things that are not flammable can become flammable, and things that are flammable can become like almost explosive, right? So now a lot of people like to check the hose before you put gas through it. I like to do it, it's probably slightly more dangerous, but it's way easier to tell if the hoses are messed up, because we want to check them for burns, we want to check them for cracks, and these are quite old, but they do get checked quite often. So let's just check and see if we have any cracks, any splits, any burns. And I like to do it with gas in them, because while you're looking, you can hear it or sometimes feel it if it's leaking, right? So we haven't lit anything yet, so it's still relatively safe, although you definitely don't want leaking oxygen. So there's like, it almost looks like a grinder mark in it, right? But I don't feel anything, I don't smell anything. We can put some soapy water on it and see if it bubbles. Does not. So it's good, right? So when you just want to do this anytime you use your torches in the shop, because you don't know who used them last and what they did to them. They could have dropped a suspension part on them. They could have driven over them. Could have been anything that could have happened to these. Like this is squished for some reason. Looks like it got driven over. I'll just check it, make sure it's not bubbly. No bubbles. Oh, there's some pretty good cracks. These might be close to the end, these hoses. And the hoses aren't expensive, it's all the other stuff. The regulators and the torch handles and stuff are quite expensive. They like to crack right here because it's kind of where they first start to bend too. So you want to check that part, see if anything's swelling or bubbling. This is almost like starting to crumble. So we're going to have to buy new hoses soon, but they're safe right now. They're not leaking anywhere, so not too bad, right? Now, I'm going to show you one other part of the setup before we light these puppies up. And it's setting the pressure. So I have this set to 10, it's still at 10. I have this set at 5, it's still at 5. The problem is when you're welding, those pressures will change. So what you're supposed to do is set the working pressures, right? And when I first set the acetylene one, I actually heard it hissing and I turned it off, right? But it should be running, and you just run it a quarter turn out like as if you're welding, and you see it drops slightly below the 5, so we need to give it a little bit more. That's our working pressure. When you turn it off, it hops up about a half a PSI for the acetylene. For the oxygen, you can see it drops quite a bit, right? So I'm going to turn it back up to 10 and turn it off, okay? So that's setting our working pressures, right? So although we're above 10 and we're at about 6 there, that's actually the correct pressure once the torches are running, which is what you want, right? Does that make sense? It's like when you set your tire pressures on your car, it says set it at 35 PSI or whatever. It always says cold. You can't do it while you're driving. You can't do it after you're driving. You have to do it before you drive. And it's because that's not actually the correct tire pressure for your car. It's when they've been rolling on the road surface, the pressure goes up. It's probably closer to 40 is actually the correct pressure, right? So what we want is that 40 PSI, that correct pressure for while we're welding, right? So we don't need this anymore. We don't need that anymore. What we need is some goggles, and we need some gloves. We need to fire this puppy up. So what I have here is what everybody calls a sparker. It's actually a flint lighter. When you use your flint lighter, you want to press down as well as across with your thumb, right? So what we do, or what I do, the green hose is oxygen, the red hose is acetylene. We're going to turn on the acetylene ever so slightly, fill the cup up with acetylene and spark it. A little more. And we got acetylene. We got acetylene. And then we're going to slowly introduce the oxygen and create a nice flame. So this is a flame that is a mix of oxygen and acetylene. This flame is called a carburizing flame. And I know it's a carburizing flame because it has too much acetylene in it, and it actually has 3 portions of the flame. So you can see the little blue bit way down at the bottom. That's the inner cone. Then we have the outer cone, which is the yellowy one. And then we have this big long blue one called the feather. It's the 3rd part of the flame, right? So what we want to do is continue to increase oxygen and pull it so we can still see 1, 2, 3, right? We have an inner cone, an outer cone, and a feather. Just keep going until there's only 2. And when you have 2 flames like this is a neutral flame, meaning that the oxygen and the acetylene are perfectly balanced into a perfect, nice, hot, even flame, right? That way all of the oxygen is getting burnt and all of the acetylene is getting burnt nice and clean, right? This is our ideal welding flame. If I go a little further, what happens is the inner cone starts to get pointy and you'll start to hear it. So you can hear the flame now, right? That's an oxidizing flame. So the oxidizing flame is not good for welding because it'll actually contaminate the weld with oxygen, making it brittle, right? So I'm going to go back out to our carburizing flame, a little closer to the camera so you can see. We have the inner cone, the outer cone, and the feather. And I'm going to pull it back into our neutral flame like that. That's our neutral flame, and a little further where we start to hear it and the inner cone starts to get pointy and bright. That's our oxidizing flame, right? Okay, so actually I hit the acetylene. Oh man. Relight, relight. This torch is old, so these valves are really touchy. And sticky. Okay. Neutral flame. Okay, neutral flame, right? So that's what we got to do. And when you want to shut it off, there's a bit of debate here. There's like A before O or up you go or oh, before A and run away, or I don't know, all this different stuff. But what I was taught by a guy who was actually, so the first guy that I apprenticeshiped under was actually a trailer heavy duty technician and a mechanic as well. And he used to weld hydrogen trailers. And he said what you do is you just kill the acetylene, and then that little snap at the end snuffs out the flame and cleans the tip at the same time. So some people may tell you to shut off the oxygen first. Some people may tell you to turn the acetylene off first. I tell you to turn the acetylene off first. Blows the flame out, cleans the tip. That's what we want, right? It's perfectly safe, okay? So that's that. Whoa. So now when you want to go and shut down the torches, you actually do it kind of backwards, right? So I got the valves on the torch handle off, but we actually don't turn these off first, we turn this off first, right? Excuse me. So this oxygen valve we had all the way open, so we're going to screw it all the way down and shut it. This one is a half a turn, it's off now. You never crank on these, you never turn them hard because they're brass, they're soft, and you can very easily prematurely wear them out, right? So what we're going to do now is drain the regulators and drain the hoses as well. Oxygen is very corrosive. Acetylene is actually inside this tank is actually not hollow, it's filled with concrete, and the acetylene is stabilized in the concrete mixed with acetone, and the acetone is very corrosive to the rubber parts and the metal parts inside the regulators as well, right? So what we're going to do is actually open it and drain off all the acetylene to get it out of here. So acetylene's not sitting in the regulator, it's not sitting in the hose. And we're going to do the same to the oxygen, drain it off and get it out of here. And this is how you want to store your torches with nothing in them, and probably why the valve was still on when I first set up the torches, right? And now what we do to make these not a bullet for the next guy is we turn them out until they're jiggly and loose, and then it's nice and safe for the next person as well. And then we're going to wind the hoses up nice and loose. We don't want these pulling hard because then they'll crack even more than they already are cracked, around in nice big loops, and hang it on the cart, and make sure that this is all soft brass and copper as well. This can't drop. We want it somewhere like fairly secure so it can't fall, right? So I like to actually wind the hose backwards. I put the torch on first, and then it's buried underneath the hose so that it can't fall, right? So it's a little bit of a tangly mess to get undone, but the torch is very unlikely to fall because it's underneath all of the hose, right? And then it'll be safe for the next person, won't get run over by the wheels or anything like that. It's not the best to loop the hoses on the regulator like this. Again, it's soft brass, and it's not the most gentle for the hose. The better carts than this have a nice hose reel on it, right? That won't kink it, it won't pull it. But you do want to make sure these are loose so it's not pulling on them. That's always where they'll crack first. You can see this one even like wants to kink now, right? And then put these in the corner where they belong, and it's safe for the next time we use it. Okay. Okay, so here is the welding torch. This is the handle assembly, the two valves, the F and O, fuel and oxygen, there, the red and the green hose going in. And then it comes up here into a mixing valve. And then this is the gooseneck. This angle is set up perfect for welding, the angle down. And if you tilt it just a little bit, the angle forward as well for when you're pushing a weld. Now, me personally, I don't set my torches up like this. I actually flip them the other way, and it's so all the valves are on the bottom so it doesn't hit on my sleeve, and I just turn the gooseneck around like that, and this is the way that I weld. So my valves are down here, easy to get to if I need to make an adjustment, and my arm's not going to move them and change the mixture on me, right? So that's the way that's done, right? So this thing, you just take off the gooseneck like so. You can see the mixing valve inside. This is the cutting torch head. You just pop it on. And now anytime you put anything on, because it's such soft brass, and believe me, this little tiny torch is expensive. This is actually mine from home. The two biggest cutting and welding companies are Victor and Harris. And this is a Victor torch. Harris is just as good. They're the two sort of major brands, right? So anytime you're taking something off, no big deal. And remember, it's soft brass, so you can tighten these, but most people don't. You just snug them down by hand, and they won't leak. You can see the seal. You can see the seal. They're a hydraulic seal, right? They seal very, very well and very, very easily. So when you put these together, the thing to do is you just hold the nut down and turn it backwards until it clicks like that, and then you know it's on the first thread so that you won't cross thread it and damage the expensive torch, right? These really can't be re-threaded. Like if you mess these up, they are garbage. So I'm going to do it one more time without talking so you can hear it. Just push down lightly and rotate counterclockwise. And there's the click. I know it's on the first thread. It's not going to cross thread on me, right? Now again, even with the cutting torch, I do it so the valves are on the bottom. Snug that guy up. And then when we light this one, so we adjust the acetylene fuel and the oxygen just runs. So this is actually the oxygen knob now. So we turn this one all the way open and nothing comes out unless you pull the trigger, right? So this is actually the cutting valve. This is what blows the molten slag through the cutting head, right? So we're going to, oops, wrong glove. Where's my other glove? It's over here. All the GoPro stuff. Turn on some fuel. And when you set the cutting torch, you want much more acetylene coming out like this, and then we'll set the neutral flame. And what the cutting torch basically is a whole bunch of little flames all at once, right? It's like having a bunch of those goosenecks going, so it heats up the metal very quickly. You can see there's about 5 or 6 of them there going, right? We're going to adjust it to a neutral flame. When I pull the trigger, it goes oxidizing, right? And that's what blows the metal through. Okay, same thing when we turn it off. We just kill the, or wait, no, the other way, sorry. We kill the fuel, snap out the flame like that, turn off the oxygen, turn off this valve too, and then we can put the torches away, right? Because we're done with them for this demo until you guys get to come to the school and play with them yourselves. So one more time, just so we don't forget. This one's all the way on, so we're going to turn it all the way off. This one's a half a turn out, turn it off. We leave those and drain the fuel, drain the oxygen. This one we'll have to pull the trigger to let it out. Wind back the valves so they don't fly out for the next person. And wind up your hose all loosey-goosey and store the torches somewhere safe, right? There's a bunch of safety features with these torches because the gases are so dangerous. This is kind of like a blow-off valve in a turbocharged car. If this was like left in the sun or it got hot in a fire, it would actually vent the oxygen off instead of rupturing the tank. And these acetylene ones, they have these little tin plugs put in them, right? And they melt, so the pressures aren't high enough to make this rupture, but this actually vents the fuel off in a controlled manner, right? So if this tank was involved in a fire, that little, it's basically made out of like solder, like it's tin. It'll melt at a very low melting point, and then acetylene flames will just blast out of the top of it instead of the tank rupturing it and blowing something up like big time, right? So these are dangerous. You hear all the stories about these things like dropping and the top blowing off and then them turning into a torpedo and stuff like that. But I mean, I've been working around them for a very long time. I've never seen anything like that happen. As long as you use them safely, they're very, very safe things to use. Okay. So that's oxyacetylene stuff in a nutshell. I'm going to clean up here and we'll move on to the